Hi everyone, welcome to my channel Design with Roosevelt. Continuing with CSWA practice problems, today we'll work on question 4.1. This is the first question from chapter 4 of the problem set that we had for SolidWorks CSWA practice set. In this question, like always, we have unit of measurement, which is millimeter gram second, and we're dealing with a symmetric geometry. You can divide this geometry into three sections. We have a middle section, which is a cylindrical section. We have a bottom section, which is a triangular section. And we have this top section. My preference is to focus on the cylindrical section first. I'm going to make this part. Then I'm going to make the bottom section. And finally, I'm going to use a polygon shape, make this top feature, and I'm going to use extruded bus to make the final feature in this geometry. So with this introduction, let's jump into SolidWorks and start modeling this part. In SolidWorks, first thing first, we need to check unit of measurement. And you can see that we have millimeter gram second as a unit of measurement, which is a correct unit of measurement. So we're good to go. Next, we need to make a 2D sketch. Let's click on the sketch, click on the sketch command, and I'm going to choose front plane. Because I want to make a cylinder, of course, I'm going to use circle command. And then here, I'm going to make a circle. Now, looking at the question, we can see that the diameter of this cylindrical section should be 9 millimeters. So I click on the smart dimension, I click on the circle, and this is 9 millimeter. Next, I want to extrude this. Click on feature, click on extruded bus, and then here I'm going to extrude this feature for 120 millimeter. Awesome. So now we have this geometry. Great. Let's focus on making a triangular section. So to do this, I click on a sketch, and then you can click on this drop-down menu from Model Tree, and I'm going to choose right plane. Okay? Now here, I want to make a 2D sketch. Let's click on line command. First of all, we know that we have 1.5 millimeter section, so I'm going to make a line here. Click on the smart dimension, and the length should be 1.5, okay? Also, we know that the center point of this line should be located on the origin of the geometry, or center point of the long line. So what I can do, I can click on this line, right click, I select midpoint. So now midpoint is selected. Hold Control, click on the origin, which is a symmetry line or symmetry point of this line. Click on it. And from here, I'm going to choose coincident relationship. Now you can see the line moved here. So basically 0.75 millimeter of the line is here and 0.75 in the bottom. Okay, so that's good. Next step, I click on a line and I'm going to make a line here. I also need the arc shape. So click on arc command and here I'm going to make arc shape. Okay. Like always, if you remember, there were many circumstances that we had a line and an arc. Usually, it's wise to apply tangent relationship to have a consistent line or geometry. So what I can do, I can click on this line, hold Control, click on the arc, and from the relationship here, I'm going to choose tangent. Okay. Next step, let's add some dimensions. The distance between this side of the geometry and this point, end point of the arc, is 25 millimeters. So I click here and that's 25. Okay. Also, we know that the radius of the arc is 5 millimeter. Click on the smart dimension, click on the arc, and this radius should be 5 millimeter. And finally, we know that the angle of this line with the horizontal line should be 4 degrees. So I click on center line because I need a reference line, and I make a center, and I make a center line here. And now I know that the angle should be 4 degrees, so this angle should be 4. And now you can see that our geometry is fully defined. Because we want to use extruded bus feature, we are looking for a contour. So we need to close this geometry. Click on line command, and then here I'm going to close the geometry. I go to this side, and now you can see we have a closed contour which is fully defined. Everything is ready to use extruded cut feature and make the feature that we want. click on Feature command, click on Extruded Cut, and then here, what I can do, I can select this contour. And here you can see the option through all both sides. That's a good option. We want to cut the geometry in both directions. Click on OK, and that's it. So now you can see that we have the feature created here. Next step, we need this feature on the other side of the geometry as well. So it's wise to use mirror command. To do this, from Feature tab, click on Mirror command. And I'm going to choose a plane. Click on a drop-down menu, and then here I'm going to choose top plane as a symmetry plane. Secondary mirror plane, we don't need that. Click on Feature to Mirror, and then the feature that we want to mirror is a Cut Extrude feature. Click on it, and now you can see the preview. Click on OK, and that's it. Okay, so now we have this part of the geometry made. Next step is even easier. We just need to make it polygon, and then use Extruded Boss feature to make the final feature. So to do this, I click on a sketch, I click on the sketch command, and I'm going to choose this side. I need a polygon. So from Sketch tab, I'm going to choose Polygon command. And then here from the center point, I make a polygon. First of all, I want this top line to be horizontal. Simply click on it, and from the relationship that you see here, choose horizontal. Also, we know that the distance between the top line and the bottom line should be 6 mm. Click on the Smart Dimension, click on this line, and this should be 6. Awesome, so now we have a fully defined geometry. Let's click on Feature, click on Extruded Boss, and then here I'm going to extrude this feature. The length that we need is 20 mm, so I change it to 20, and that's it. Great. So now we have this polygon feature made. Final step is to add a chamfer. According to the question, we need a 1 mm chamfer with 45-degree angle. Click on Feature, click on Fillet drop-down menu, and then click on chamfer. And then here you see that the distance is basically 10 mm. I change it to 1, and then simply I can choose this edge. You can see the preview, click on OK, and that's it. Awesome. So this is the final geometry. Now it's time to check the total volume. Let's go back to the question and check the total volume in the question. In the question, you can see the total volume. Total volume is 7,393 cubic millimeters. Let's go back to the SolidWorks model and find the total volume. In SolidWorks, in order to check the volume, you can click on Evaluate, then click on Mass Properties, and here you can see the total volume. The total volume that we have for our model is 7,393 cubic millimeters. This is exactly the same as the numbers that we found in a question, which means that our model is correct and accurate. Okay, awesome. I think that's a wrap for this video. I hope you guys enjoyed this video. If you have any comments or feedback, please leave comments down below. Thanks again for watching. My name is Rusbe. Hope to see you again soon in the next videos.